as the name suggests, relation. Something that connects two people is known as a relation. Okay. For example, the relation that connects you and me is that I am your teacher. Okay. And you are my students. So that is the relationship that we are having with each other. Now in mathematics, what is a relation? Okay. So basically, this is my set A. This is my set B. And I have a relation जिसका नाम R है. Okay. So I have a relation from A to B, and something over here A is mapped to something over here B. Okay. So A goes to B. That is mathematical language. A goes to B. B is called the image of A. A is called the pre-image of B. Okay. Now we can have something over here C, and C goes to D. Okay. C is called the pre-image of D. D is called the image of C, and so on. Okay. All right. Now, this set A is known as domain of R. This set B is called codomain of R. Okay. We have to understand, and how do we write it mathematically? R is a relation from A to B. Okay. And any element of R should be written down as A comma B, where A belongs to A, B belongs to B. Okay. So that is how my relationships are defined. The first element is in the domain. The second element is in the codomain. Okay. Now we will discuss certain examples and see what is going to happen. How are we going to write? Okay. So suppose I have this relation 1, 2, 2, 3, 1, 5, 2, 6. Suppose I have this relation. The first elements, now this is my set A, this is my set B. My relationship is from A to B. First set contains 1 and 2. Second contains 2, 3, 5, 6. You see, 1 is being mapped to 2. Okay, 1 is being mapped to 5. 2 is being mapped to 3. 2 is being mapped to 6. Okay, so here, what is your domain? Domain is 1, 2. What is your codomain? Codomain is 2, 3, 5, 6. Now I introduce a new term. What is the range? 2, 3, 5, 6. What is range? Range is the set of all possible values assumed by R. Okay. In the relationship, whatever values the relationship is assuming, those constitute a part of the range. Okay. So this is my relation. So what you can see in a relationship, in a relation, one element is going to two images. You can see 1 is going to 2, 1 is going to 3, 1 is going to 2, 1 is going to 5, 2 is going to 3, 2 is going to 6. So one element can have two images. So this is relation. So what is relation? We have one set sitting over here, one set sitting over here. I have a map relationship. This element is being mapped to some other element over here. Okay, that is what I mean by relation. Now, let me come to functions. So first we define relations, and now we define functions. Now, what is the thing that separates a function from a relation? Now, it is that one element in the domain, okay, one element in the domain cannot have more than one image, okay? And in fact, we have exactly one image, because we cannot have a function where there is some element which does not have an image. That is not going to happen. So function, what is going to happen in a function? This is my set A, this is my set B, this is 1, this is 2. Suppose I have 3 here, 4 here, 1 goes to 3, 2 goes to 4. Yes, it is a function. Why it is a function? First of all, it is a function because 1 is mapped to 3, 2 is mapped to 4. 1 is not mapped to more than one element, 2 is not mapped to more than one element. It is a function. Let's talk about the relation. Suppose I have A here, B here, I have 1 here, 2 here, 3 here, 4 here. Suppose I have this situation. 1 goes to 3, 1 goes to 4, 2 goes to 3, Okay, so now this is not a function. Why it is not a function? Because 1 is going to 3, 1 is going to 4. So 1 in the domain has more than one image in B. It cannot be a function. That is the basic differentiation between a relation and a function. Okay, so if in examination, the first basic question that is asked from relation and function is that identify whether it is a function or not. That is the first question that is encountered. First basic question. Okay, so let's see. For example, you have this question. A is equal to 1, 3, 1, 4, 7, 8. Is it a function? Straight away, no. 1 is being mapped to 3, 1 is being mapped to 4. This is the most basic way of writing a function as a set. Okay, most basic way of writing a function as a set. So what is the moral of the story? Every function is a relation. Okay, but the converse is not true. Okay, fair enough. So that is the basic definition of a function. So first we understand functions and then we proceed with its characteristics. One more thing that you should bear in mind is that if this is my set A, this is my set B, if this is my domain, this is my codomain. Okay, now if I have 1 here, I have 2 here, I have 3 here. Suppose it is mapped to 0, suppose this is mapped to 7, suppose this is mapped to 3, and suppose there is one more element here, say minus 8. Now, this is a function. It is a possibility that some elements over here are such that there is no pre-image. That is perfectly fine. There might exist some elements in the codomain not having a pre-image. Perfectly fine. But we cannot have an element sitting over here with no image. Out of question. Okay, I want an image for 4 under a function. If 4 is in my domain, we want an image. So what is the moral of the story? Nothing can be left behind here in the domain. Okay, things can be left over here. I hope it is understandable. So nothing should be left here. Things can be left here. Okay, that is why we have two terms, codomain and range. So in this question, the codomain was the set 0, 7, 3, minus 8. But the range was the set 0, 7, 3. You see, the range is a proper subset of codomain. That is a perfect possibility. Okay. And for such functions, we have a beautiful name. Okay. We have a specific name for such functions. These are not onto functions. Okay. So if my codomain and range become equal, okay, this is known as an onto function. Okay. Or a surjective functions. These are technical terms in mathematics. You should know them. These are onto functions where domain, codomain, and range are equal. Okay, so here one element is left behind. It does not have a pre-image. It is not an onto function. Okay, so we have discussed what is an onto function. We will have a definition later on.